Welcome everyone. Some brief introductions. Mark Corluka, who's from the Victron community, who's an end user but enthusiast and has experience with custom development inside the Victron ecosystem. Yeah, so this webinar is basically the extent of the support aside from the software integration itself in the platform in terms of getting people started, and then really it's up to them to follow their own intuitions and research and experimentations to find the result and to support each other too via the modifications based on the community. The point of Node-Red is that the potential is infinite basically in the hands of the right developer and the right application. So we just give you the tools and then it's on to all the people in the world out there to figure out how to implement it and integrate it in their own systems.
So this is our presentation for today. We have a customer and also a friend, Mark. He knows a lot of things about Node-Red and he already built a very complex Node-Red flow, and we would like to share that flow with you and see what is possible to do if you like to spend some hours or some nights playing with Node-Red. Mark? Your turn.
Well, so my name is Mark. I'm an end user. I've got a technical background, but I don't have any programming background. So I've got no prior programming experience prior to using Node-Red. And I use Node-Red in an off-grid setup and a few other little systems for a bit more advanced automation and control, such as control of excess power diversion to a water heater, integration with some external devices, and also I'll set up a Node-Red dashboard with a graphical user interface that basically covers the whole Victron system. Node-Red's been in progress, integration into Venus for quite some time now, about four years in total, actually. It's a huge amount of work getting it in there, and it's a real credit to Victron to have done this, I suppose, for us users, because it's quite a huge and totally free enhancement, which has got many benefits for advanced users that have specific or unique requirements in terms of control or automation. Node-Red's very powerful. It's very flexible. It'll do a simple task, but if you want to do something much more advanced, it's also quite capable. It's really how much effort you want to put into it, and how much spare time you have from tinkering. So there's no real limitations. It's more on the actual user and the time and effort. And there's a fairly wide user support group out there as well to gain some assistance and examples, etc. So just as an example of that, just 1 second, I'll switch to the Node-Red site. Okay, and Node-Red is generic. It's not Victron specific. The Node-Red site and community offer a fair bit of guidance and support. If you're starting out, visiting the Node-Red site and looking at some of these areas is probably a really good start. Things like the actual user guide, if I click on that, it's got a really good explanation about all the sort of basic elements and also all the basic nodes down here. If you were to click on any of these, it gives you a lot more information and just like a good high-level overview to help you get started. And going back over here, there's also this tutorial section, which describes some fairly simple flows, first and second flow, but there's also a Node-Red YouTube channel. And again, if you're starting out, if I just expand that, visit this Node-Red Essentials playlist. There's, 19 videos. They're all fairly short in duration, ranging from, about a minute to about 3 minutes each. So it doesn't take long to get through it, but if you spend an hour or so, I suppose, watching all those, if you start off with very minimal knowledge, you end up with sort of like a firm base to start programming on. And back to the Node-Red site. This cookbook as well, this is also very helpful. It's got a bunch of examples that are common tasks or problems people try and solve using Node-Red. Again, if you need to do something particular and you're not quite sure, you can have a look here, see if there's an example or something similar. This will explain some solutions to achieve that desired result. And also there's examples flows as an example. That's a simple one. And I think Derek already went over this, but if you have excessive data rate and you want to slow that down, you can limit it using this delay nodes as a simple example, but just one of the examples here. Another resource here is the Node-Red forum. So if you click there, again, there's a full forum focused just on Node-Red, and fairly big community there to provide support, because most of the time, I think issues that you'd encounter or problems that you're trying to solve and you're not quite sure how to do are probably generic problems, and this community here might be more useful than the Victron community, which is a bit more broader. So this is just another option to consider. Okay. So next part that I wanted to go over is context storage. And I think that's actually touched on here in the documentation, maybe here, working with context. So Node-Red by nature, it requires a message passing through the nodes and the wires. And that simple arrangement works most of the time, but sometimes it has drawbacks because it doesn't allow sharing of data between nodes and maybe logic-based decisions based off the value of a different node. A solution to that is what's called context storage, and it's similar to like the dbus on the Victron OS, and it allows you to save values to memory on the side there, and then you can access those memories either by another node on the same flow or even other nodes on different flows. And there's some 3 levels to context storage. There's node, flow, and global. These 3 levels depend upon how far you want to share the actual information. So in general, flow is probably the most common one that you use, and it lets you share the data with any flow on the particular page. So if we go into the example that I prepared, you can store the data a few different ways. You can use a function node. Probably the most simple one is just using a change node. So you can just drag a change node onto your screen, and then when you open it up, you can set it to set and then flow, and you can select a suitable name here. You click done. Your second part would already be set to message payload, so just leave that there. Click done, and then what it'll do is it'll get whatever the input message is, and it'll save it as a context data. So up the top here, there's a drop down. If you go to context data, then it shows you the different levels, node, flow, and global, and we're saving to flow here. I've already clicked the charging here, and it's saved it to the battery state parameter, and you can see here charging. If I update that to idle, I've got to manually refresh, then you can see it's saved as idle. But I can pick that up from any other node and use that data, I suppose, to then make other decisions or to incorporate it elsewhere. That doesn't have to be just in that particular line. Similar kind of thing here, where I'm saving a power parameter. Previous value was saved as 500. I just sent 1,000 there. Again, if I refresh, you can see there's 1,000 there. And then you can also make it a little bit more complex. But if you have a lot more data, it's better to save it as an object where you've got different levels. So you can save it as flow.multi.voltage, for example, and then message.payload as the input. And we'll just connect it up to one of these just to give a quick example. And maybe we'll copy that one. And we'll have another one as current. And I'll save that there. And I'll just deploy that change. And then I'll just send each of those a value. And if I refresh on the right here, you can see I've got the multiplus area, and I've got an object here with those 2 values. So if you got multiple, like a big list of values, it's a lot neater doing it like this, so you can keep track rather than having totally separate parameters on the side. What this can be used for then, as I mentioned, is that you can use a value of one particular section of the flow to determine the outcome of another. So over here, what I'm doing is I'm just injecting a number at a regular rate, and then I've got a switch node here, and I've got a condition set to look at flow.battery state. And if it's equal to charging, then I'll let the message through to output number 1. And if it's not equal to charging, then it'll stop. So what we can do here is we can go to our debug screen, and I'll just reset it. Actually, we'll see what we have that set to at the moment. Sorry, just 1 second. So I've got it set at idle now. So this should block the message. If I go back and I send number 2 through, you can see I'm getting no messages here. But if I change this up here to charging, then see all of a sudden that 2 number from this lower section, which has no connection, is being let through here. Same kind of thing. I can stop it by sending something else. So this is quite useful when you're doing a little bit more advanced flows and you need to get data from one section and share it with another. That leads on to the example that I prepared here, which is, it's not super advanced, but I think it sort of demonstrates a few different aspects. And this resolves, I think, a real life usage condition of making a decision based off on value, where the value is maybe dynamic and you need to have some hysteresis between the on and off, and you want to have a countdown timer before switching off and switching on once that condition is met in order to avoid false triggers. So I've got no function nodes here, so it's all just pure, I suppose, simpler nodes set up in a particular fashion. Again, if you're creating something like this, it takes a bit of trial and error, and it's quite useful to see how the nodes work by clicking on the nodes, looking at the information section over here, and you'll get some details and info over here. This will give you a bit of a better understanding rather than just flicking through the menus and guessing, particularly if you want to do some more advanced features like sending it dynamic messages. But in this flow where I'm feeding it with some numbers, there's some logic to determine if it's above or below certain thresholds. And depending on that, it'll start an on counter or an off counter. And if that condition is met for the required duration, then it'll turn your switch on or off, as a simple example. And these settings can all be changed dynamically based off these conditions that we've set here, saved to our context storage. So if we go to the context storage over here, you can see that this is the information that we've saved already. So we've got our off delay, off threshold, on delay, on threshold, and output state. And I've got this linked to a simple dashboard. Just got it over here. I find it quite useful to have a dashboard set up when I'm trying to set up flows, because you can have things like sliders and you can visualize the output, particularly if you need to change variables to see if it's working or not. It's a lot easier to have a slider rather than having multiple inject nodes. But yeah, looking over here down the bottom, these are our on and off conditions. So on delay is 20 seconds, off delay is 10. I can change that to whatever number we feel like, and I've made the on and off threshold as well dynamic. So again, we can just use that, change that to whatever we feel like. We can see our states off. So over here, if I was to slide that manual input higher than the on threshold, you can see that our on counter starts counting down. And when that gets to 0, this will switch on. But if this was a dynamic value that was oscillating and then it went back below the threshold, you can see that counter stops and it resets. So what I'll do is I'll just reduce that so we can get it to switch on pretty quickly. I'll put it down to 10 seconds, and then you can see after 10 seconds, the output hopefully should switch on. Okay, so that's switched on, and that's driving one of my relays as well. Same kind of thing. Hysteresis zone in the center, so nothing happens, there's no change. Once we go below the minimum of 25, the off counter starts counting. Once it gets down to 0, yeah, that'll switch off. So that's a bit of an example of dynamically changing the inputs into some of the nodes, which is not necessary, but sometimes can be useful. Context storage, yeah, and doing a bit more of a complicated example with time delays, etc. inbuilt. That was all I was planning to present. There is a UI that I've got as well, which I can share. Yeah, so this is a little user interface that I've set up and incorporates most of the products that I have here just at home in my test system. As an example, I've got some images here where if I click on the image, you'll go to the actual device. So I can switch between a battery management system, a multi-plus, a solar charger. And under the servo, I've actually even got VRM embedded here. So it should bring that up in a second or two. So I've basically had to import all these values, save them as a context storage, and then I read from them every second and I send it to the dashboard. And then I've got controls set up as well. So for example, now this is set up to inverter only and it's not charging, but if I was to switch that to on in a second or so, hopefully it should start charging from the grid. So you can see there, it's ramping up. Go to our EMS, same kind of thing. We can see how much volts, current, power is charging with, state of charge, set up how much amp hours are remaining, how much time's remaining now that it's charging. It's moved to infinite. Yeah, we've got some LEDs on the side to have the allow to charge, allow to discharge, and contact states. Even things like this image, this icon here, this is set up with a few different images based off different trigger thresholds. So this icon, the actual battery level will increase as the battery gets charged. Yeah, if I click standby, it'll shut the whole system down, so I don't want to do that. But yeah, I think you get the idea. It's dark here at the moment, so there's no solar or anything.
Mark, we have a few questions regarding your dashboard. I was expecting that.
Yeah.
They're asking about what dashboard it's used. It's used in your case. Probably is the classic dashboard, but you are applying some.
Yeah, I've got a lot of CSS.
A lot of CSS inside. Okay.
Yeah, it's the normal dashboard, but I've got a lot of CSS in order, overrides, in order to have sort of the image in the background, to have all the coloring, to have the radiuses, to have the shadow. Yeah. And I'm using a SVG node to have this logo at the top here, I think. Yeah, this is a multi-state switch node over here.
Also, we have a question if it's possible to share this flow example. Probably not. It's way too complicated for sharing it between devices.
Yeah. I prefer not to, sorry.
Okay. Thank you, Mark.
Thank you.
Bye-bye.
Thank you all.
Thank you. See ya.